Welcome to RLD Academy. In this video, we'll find all the possible solutions of x to the power 8 equals to 16, this equation. This kind of problem we frequently encounter in different areas of math, physics, and engineering. I'll give you two methods. First method is very straightforward, but it is laborious and time consuming. In this method, we'll try to find out all the factors of this equation x to the power 8 equals to 16. So this was that we'll have 8 such factors for this equation, and we'll find all the factors and we'll find the solutions. And second method is more elegant and we'll discuss later. Now start our first method. Now this one, x to the power 8 minus 16 equals to 0. First, we can go for this one. This x to the power 8 we can rewrite as x to the power 4, that's square, and this is square of 4. Then it is a square minus b square. So we can have two factors. One is a plus b, and another one is a minus b. Thus, we'll have x to the power 4 plus 4, and another one is x to the power 4 minus 4. Now again, we can have factors for this one. So this one, we can go for x squared, that whole square, and this is the square of 2. Again, a squared minus b square form. We can go for it is same. This is your x squared plus 2. This is your x squared minus 2. Now further, we can have factors for this one easily. So we can rewrite as this is a x of this is square of x, and this is the square of square root 2. Thus, we can rewrite as a square minus b square form. So we have these factors. This is your x to the 4 plus 4. This is x squared plus 2. This is x plus square root 2. This is x minus square root 2. Okay, so we are having these factors. Now we need to find out the solutions of this equation. And this one, this factor will give you the solution x equal to square root 2, because x minus square root 2 equals to 0. Thus x equal to square root 2. This is one real solution. Okay. And second one, this factor will give you another solution x equal to minus square root 2. Right? Now, this factor x squared plus 2. So what are the solutions? Right? So we can solve this equation x squared plus 2 equals to 0, destructible. Now, this x squared we'll consider as minus 2. Thus x equal to square root of minus 2 plus minus sign we can consider. So two solution we will get. Thus one is positive, other one is negative. Now square root minus 2 we can rewrite as square root 2 times square root minus 1. Now this one, this is not real. So this is one imaginary quantity. We'll consider one symbol small I to represent the square root minus 1. Thus x equals to plus minus square root 2 small I, where small I equals to square root minus 1, and this is one imaginary quantity. Okay. Now if this imaginary quantity is defined, then with the help of this one we can find all the solutions of any order equations. Now consider this first term, x to the power 4 plus 4. So you will find that here we should get 4 such solutions. Now we can expect from here its solutions are all complex. It's not real. Let us find the solution for this one. First we will try to get again some factors of this equation, because this is power 4. It's very difficult to handle. At least we should get the second order, and it will be better if we can get first order factors. So this thing we can rewrite as the square of x square, and this is 4 means square of 2. So this is a square plus b square form that we can replace as a plus b, that square whole square, minus 2 times a into b, because a square plus b square equal to a plus b whole square minus 2 times a into b. So this form. Now this one is becoming 2 into 2 is 4, 4x square, and this is minus sign. Now this one is again x square plus 2 then whole square, it's minus. This one I can write as 2x whole square. Right? So again it is a square plus b square minus b square form. So I can have two factors, a plus b, a minus b. Thus we can write as a square plus 2x plus 2. The second one is x square minus 2x plus 2. These are two factors, and that product will be 0. So this equation we can replace by these two factors, and this is the equation. Now we need to solve it. So we'll consider these two factors. From each factor, this factor I will get two solutions. Similarly, next factor again we should get another two solutions. So total 4 solutions we will get here. Okay. So let us consider the first factor, this one. We'll try to find out the solution. So this one we can rewrite as x square plus 2x plus 1 plus 1. So replace 2y plus 1 and plus 1. Then we'll try to combine these first three, x square plus 2x plus 1, and that is nothing but x plus 1 the whole square. And this plus 1 will to consider the right hand side as minus 1. Okay, now we'll take square root. So x plus 1 will become plus minus square root minus 1, and already we have introduced this I symbol. So square root plus minus 1 is equal to I, that is plus minus I. So x equals to minus 1 plus minus I. So two solutions, one is minus 1 plus I, other solution is minus 1 minus I. Similarly, from this factor we will have another two solutions. Just only difference is that here it was positive, here it is negative. Thus here we will get x minus 1 equals to plus minus I. Thus x equals to plus 1 plus minus I. Two solutions, one is 1 plus I, another one is 1 minus I. Okay. So we have 4 such solutions, plus minus 1 plus minus I. Okay. Right. Now we'll try to understand the pattern of these solutions. Let us plot all the solutions in a complex plane. In this complex plane, this axis is real axis, this is one imaginary axis. Okay. Now we'll place all the roots of this equation in this complex plane. The first one, this one, its root is x equal to square root 2. It's real. On the real axis, x equal to square root 2. Suppose this distance is square root 2 from origin. Okay, center point. Next, second one, x equal to minus square root 2 is on negative side. Okay, it is also real on real axis. Right. So two solutions we have got, they are real. One is x equal to square root 2, other one is x equals to minus square root 2. Next, these two solutions, x equal to plus minus square root 2i. So perfectly imaginary. This is here, plus square root 2i. Another one is minus square root 2i. Okay. Next, we will consider this factor x to the power 4 plus 4 equals to 0. It will give you the 4 solutions, these solutions. So we can place these 4 solutions in complex plane. We'll get these 4s. First one is 1 plus I. This is 1. This is plus I. Second one is plus 1 minus I. This side minus 1 plus I. And this is minus 1 minus I. So these are the 4 solutions. right? Now, it is interesting to see that this all the 8 solutions, they're lying on a circle with the radius square root 2, okay, and they're equally spaced, okay. You see, it starts from here, then this point, then this point, this point, okay, every 45-degree angle, okay. Now, before going to the second method, I'll discuss something about this complex number, because second method will work on these complex methods, complex numbers, okay. So let us consider this thing, complex numbers in complex plane. So already I've said that I is considered as square root minus 1. This is used because to solve this equation x squared equal to minus 1, we can't get any real solution for this equation. We need to consider one imaginary term, small I, okay. So this is the equation x squared plus 1 equals to 0. Its solution is plus I and minus I, okay. Now to solve this kind of equation, x minus alpha, that's whole square, plus beta square, and alpha and beta, these two are real. Then the solution is, of course, it is not real because here it is a plus sign. So its solution will be of this form. This is alpha plus minus I beta. So this number is your complex number. It is having one real part here and one imaginary part, this part. Okay, this imaginary part is beta and real part is alpha. Right. Now, this is your perfectly imaginary number, small I, that I have considered. So this is your real part, this is your imaginary part. This total is called complex number, and that we can represent in a complex plane. And this plane, this is real axis, this is on imaginary axis. This is your alpha and this is your beta. Thus this point is alpha plus j beta. That imaginary or this complex number we can locate at this point. Okay, right. The same point we can locate in different coordinate form, that is called polar coordinates. We can consider that the radius or distance from origin, this point is having on distance from origin, and that distance is r, and it can make one angle with the real axis. That angle is theta. So these two variable, one is r comma theta. This coordinate is called polar coordinate. So with this aspect of this polar coordinate, also we can represent these complex numbers in complex plane. Okay. So this alpha plus I beta we can write as r is a magnitude part and this is the phase part. This is called magnitude and this is called phase, this angle or phase. Okay. We can rewrite this thing as r e to the power I theta. Remember here this e is not a symbol, rather it's a quantity and its power is I theta. We can calculate its power, right? And where this e is the Euler's number and that value is 2.718283 like that. Okay, and this e to the power I theta we can expand as cos theta plus I sin theta using Euler's formula. So this is very much useful, Euler's formula. E to the power I theta is a compact form. We can expand as cos theta plus I sin theta. So in one video in future, we'll discuss this thing in detail and we'll show you the use of Euler's formula in different areas. Okay. Now, you can notice that this one, if this is r, this is theta, this is your r cos theta, and this height is r sin theta. So actually alpha is r cos theta, and that you can easily understand here. So if I replace it to power I theta by cos theta plus I sin theta, the real part is becoming r cos theta, and imaginary part is becoming r sin theta, right? And If these two are given, alpha and beta are given, we can find out the magnitude R. R is the magnitude, is square root of alpha square plus beta square. And this phase part, theta, equals to tan inverse beta by alpha. Okay, fine. So this is the complex number we have considered so far. Now we'll take one example to show that how it is useful. Now consider x equal to 1 plus I. Okay, and this is your complex number. Now radius, this magnitude I can compute easily. R equal to square root 1 square plus 1 square equal to square root 2. And theta is tan inverse 1 upon 1. Tan inverse 1, that is equals to 45 degree or 5 by 4 radian. Right. So we can write this x as, this is the magnitude square root 2 and e to the power I pi by 4. This is a compact notation. Right. Now if I want to compute x to the power 8, then 8 times you need to multiply 1 plus I. It is laborious thing. But if I use this form, this polar coordinate form, then it's very easy to compute. You see, if I consider this power of 8, then we can take the power of 8 of this right hand side, this one, and we'll get this magnitude power of 8 as well as this power of 8. So here square root 2 power of 8 and it is e to the power I pi by 4 times R, because a to the power m whole to the power n equals to e to the power m into n. So e to the power I pi by 4 times 8. So now we can simplify this one. So this will become 2 to the power, so square root means half power, half into 8. And here this 4 and 8, they'll cancel, you will get 2. So e to the power I 2 pi. So this is becoming here 2 to the power 4 means 16. And this is e to the power I 2 pi, that we can expand, cos 2 pi plus I sin 2 pi. Now cos 2 pi, its value is 1 and sin 2 pi, its value is 0. That I can use, thus we will get 16. It's very simple to get. So x to the power 8 equals to 16. So you can see that already the solution of x to the power 8 equals to 16, the solution, one solution is 1 plus I, that we had seen earlier. And we have checked this one, it is really true. Because if I consider 1 plus I, its power of 8 is becoming 16. So it's verified. Okay. Now we'll use this kind of concept to solve this problem. Okay. Now before that, again, this in this complex plane, already I've said that this polar coordinate, if I consider this is r and theta. Now if I keep r constant, suppose r equal to 1 and theta will vary, then obviously the radius is constant and it will make one circle to rotate in this way. Okay. So this circle is called unit circle if the radius is 1. Okay, radius could be anything, could be different from 1, but every time you will get one circle, right? So if you start from this 0 degree angle, so at this 0 degree angle on the unit circle, this point is e to the power I into 0 degree, means cos 0 plus I sin 0, and cos 0 is 1. Okay, sin 0 is 0, thus it is 1, right? And second one, we consider theta equals to pi by 4. So point is here. So e to the power I pi by 4, that will give you cos pi by 4 plus I sin pi by 4, and both will have 1 by root 2 value. Thus 1 by root 2 times 1 plus I. And next one is this one. At 90 degrees, suppose if I consider, then this point is on the imaginary axis. So obviously it should have only imaginary term, no real terms. And e to the power I pi by 2 is cos pi by 2 plus I sin pi by 2. Sin pi by 2 is 1, but cos pi by 2 is 0. Thus it is only I. Right. Next, theta equal to 3 pi by 4, and this is the value 1 by square root 2 minus 1 plus I. And this one at theta equal to pi, it's again in the real axis, e to the power I pi equals to -1 because cos phi equals to -1 and sin phi equal to 0. And next, if I consider this angle, theta equal to 5 pi by 4, then we'll get this point 1 by root 2 times -1 minus I. And if I consider theta equal to 3 pi by 2, again it is imaginary, but this time it is minus I. And if it is theta equals to 7 pi by 4, then its position is 1 upon root 2 times 1 minus I. Now again, if I consider 2 pi, theta equal to 2 pi, then it will come to the same point. So it will rotate. Now if theta is more than 2 pi, you will get the similar values, right? Now we'll consider our second method. We'll try to solve this equation. X to the power 8 equals to 16, meaning 2 to the power 4. Now what we will do, this 2 to the 4 we can rewrite as 2 to the power 4 times e to the power I 2n pi. As well, already I said that this point will get again if I rotate by 2 pi radian. Okay, so e to the power I 2 pi equals to 1. So again e to the power I 2 pi means e to the power 2 times of 2 pi. Again it will be means 4 pi. Again it will be 1. E to the power I 6 pi. Again it is 1. Thus e to the power I 2n pi, where n is the integer, all integer including 0 and positive 1, negative 1, positive plus 2, minus 2, all those integers. Okay, all integers, this is equal to 1. So this is one general form. So on the real axis, this 1 we can replace by e to the power I 2 into n pi. This is very, very important. We'll be using this form frequently. So it is very easy now. What is x? X equals to the 1/8 power of this form. So it is 2 to the power 4 times 1 upon 8 this power. And here e to the power I 2n pi upon 8, right? So this will give you 2 to the power half means square root 2, and this is 2, this 2 4 will cancel, so e to the power I n pi by 4. Now we'll vary n and we'll get in this all solutions, 8 solutions for these equations. We'll start from n equal to 0. So with n equal to 0, so this value to the power 0 equals 1, square root 2. So this position. So you see, this value is 1, just only this magnitude is multiplied. This square root 2 into 1 is square root 2. Next, with n equal to 1, already I have seen that at 5 by 4, the point is 1 upon square root 2, 1 plus I. So then square root 2 is multiplied. So this square root 2 will cancel. I'll get only 1 plus I. Right? Next, for n equal to 2, with this one square root 2 multiplication. N equal to 3, with this one square root 2 multiplied, that means minus 1 plus I. This is the solution. With n equal to 4, this is minus 1 times square root 2, thus is minus square root 2. Then n equal to 5, this point minus 1 minus I. N equal to 6, with this one square root 2 is multiplied, so minus I square root 2. And last one, with n equal to 7, this is 1 minus I. Then again to repeat, you won't get new solutions. This one and this one. So if you vary again, if you consider n equal to 8, it will coincide with this point. Then n equal to 9, it will coincide to this point. Okay. So these are the 8 solutions. We will get all the solutions at a time. Okay. This method is most effective, most elegant. Okay. Now you see that the first method is not useful always. I'll give you one homework problem. Can you please solve this one? X to the 5 equals to 1. Can you get the factors of this one, all the 5 factors? I think it is really difficult. So can you solve this problem? You may apply the second methods and find the solutions, and please share your solution in the comment section. Right? If you enjoyed this video, please push the like button. Okay, thanks for watching.